All right, so we'll continue with the genetics and learning videos, and this one is going to look at learning, and we will start with the first one, the non-associative learning. We'll talk about habituation and sensitization. I always struggle with that word, and then some associate learning later with classical and operant conditioning, which we already mentioned once before. Okay, so habituation, we'll start with that. And you've all seen this, is where you get used to something. What happens is certain sensory information comes in and then our body responds, but we can habituate to it. We can get used to it. People that live in noisy areas. I have a friend who had a house in West Covina and his backyard backed up right to the freeway. I mean, literally right there in the freeway. Extremely loud. And you could tell he didn't notice it. It was something that there was never any damage to it. There was never a problem with it. So it was something that just kind of phased out. And so it's not, you either have fatigue where you just wear out the neurons themselves and they stop firing, or sensory adaptation where your brain figures out that this is not important, and then it just shuts that stuff down. For instance, your sense of smell. You might walk into your house and there's an odor, and hopefully it's not bad. Friends come, oh, you got cats or whatever. But it might be something that you don't notice yet somebody that first walks in does. But as you're in there, that tends to kind of disappear. And it disappears because your body has decided this is not of importance. There are things that I need to pay attention to more. And so here, this is a local organism. It's a sea hare. It's related to snails and slugs. It's a gastropod. And what happens is they did this where they just kept poking it. The siphon on the back, there's a little siphon back here. I think that's the siphon actually right there. And so what happens is they just kept touching. And at first it started pulling it away. You can see the little neurotransmitters being pulled in. And then after a while, nothing happened to it. So this animal just decided finally that it's not a big deal. So habituation. The next one is sensitization. Again, I have trouble with that word. But the idea behind this is you enhance response where it keeps happening and then you overreact. I love the picture of the dog. That is a dog that has some issues. And hopefully that's not your dog, but it strengthens that previous response. And so pay attention to what follows. So in your life, if something bad happens and it's associated with something, when you hear that, you immediately get on edge. And maybe even overreact to it, and you're very well aware of what's going on. So these are two of the things. And then again, just a reminder that where some things fit in. We have Ivan Pavlov, again with the salivating dog. So I want you to know the unconditioned stimulus, the UCR, the CS, and the CR. So the unconditioned stimulus is food. The unconditioned response is saliva, salivating. The conditioned stimulus was the bell, and then the conditioned response was salivating to the bell. So we didn't make that real clear the last time we talked about it. So that's what those are. And then the Skinner box, again with operant conditioning, and this one was active avoidance learning and passive avoidance learning. And so active responses, you have to physically move to get away from something that's bad, like a little shock. And then passive avoidance, animals given negative stimulus for an already existing response. So it might be, hey, I'm not going to go over there because I know if I go over there, it's going to be bad. All right, and to add to this, I want to talk about biological significance. It turns out our brains don't really memorize things or associate things well if they don't make any biological sense. So they did a test on mice, and what they found out is taste and nausea can be associated. So what happens is they let them drink something, it makes them sick. And now that taste, anytime they taste it, even if it's a flavor that won't make them sick, it's associated with something that makes them sick, they will immediately not deal with it. And then the same, a really loud sound, and then they get a shock. Anytime they hear that loud sound, obviously they're expecting the shock. But what they found out is it's hard to get the sound to make them nauseous because that doesn't biologically make any sense. And so this cross section coming across here is harder to teach. I'm not saying you can't teach it, but what I'm saying is the animal is not as likely to associate those two things because it doesn't make any sense in the wild, where, you know, how they've evolved. It just is not connected. And we can see that with bats. So this is a real study where they're adding toxins, and they have asynchronous, immediate toxin and delayed toxin. And what they found out with this, very interesting, is vampire bats don't seem to respond to toxins, control, immediate toxins, delayed toxins. Doesn't matter because they are specialists. They eat one thing. And so they don't really have any options. So that doesn't seem to really register with them. Whereas in insectivorous bats, it does matter. And what you'll find is they'll eat the control. The saline doesn't affect them. Asynchronous toxin means the toxin's given to them, but not with the food. And so they're not making any association. So they continue to eat the animals because they are not getting sick immediately or even later. Now, what you noticed is the immediate toxin or delayed toxin. So if they get sick immediately or get sick within a day, they remember, hey, and we do that. You might have eaten something or drank something, that tequila night, whatever it was. And then now you can't eat that or drink that anymore because your brain has made that association. And we will stop our share and go get a drink.